Hi there. In our last episode, I shared with you how to interact with a Bluetooth Low Energy device from a Raspberry Pi with Linux using DBus and Bluez. I did a detailed step-by-step walkthrough so we had a clearer picture of the sequence that we have to follow in order to talk to the sensor. Then I repeated all the sequence again, but this time focusing on the DBus messages that were exchanged between the DBus tool, the command line DBus tool, and the Bluez stack. So we could use those messages when we write our code today. Now it's time to put that knowledge in practice and write a small application that will allow us to talk to the firmware of the Raspberry Pi Pico that we wrote in episode 2. Then we will be getting the value of the temperature and using it. Yeah, I know I said that we were going to interact with noise, and we will, but not yet. The application that we will write in this episode is going to be run from a Raspberry Pi 4B. That's our collecting station. You can use most other Raspberry Pi models, but I strongly recommend you to use an Ethernet cable to connect to your TCP/IP network and disable the Wi-Fi. Otherwise, it will interfere with your Bluetooth communications. I will be doing all the development using Visual Studio Code from my MacBook Pro. And I will connect to the Raspberry Pi using SSH. In order to do that, you need the remote SSH extension installed in the Visual Studio Code. And the first time you connect to your Raspberry Pi, it will take a little bit longer because it has to do the initial setup. If you use Emacs instead, Trump is available out of the box. In any case, we will be holding our project in the Raspberry Pi, and we will be doing all the editing and compilation from there. You will need some software installed in the Raspberry Pi. At the very least, we will be using Git and CMake. Git is the version control software, and CMake is the build system that I will be using for this project. The C++ compiler and its frontend, G++, comes installed by default in Raspberry Pi OS for the Raspberry Pi. But if you prefer to use LLVM, you can install the CLang package. In any case, we will need to install sdbus-c++. That is going to be in the library that will provide us with the C++ bindings to interact with DBus. There are other alternatives, and you can go with them, but in my opinion, sdbus-c++ is the one that has better maintenance and better documentation. I'm going to write this project from scratch. So I want to be sure that we start with the same set of initial files. I'm going to start with a very simple main CPP, and I will then write the initial instructions to build the executable that we will be using throughout the episode. Our initial main CPP file is just going to print a message. So let's go here, let's create main.cpp, and in the file we're going to include IOStream, have a main function, and in the function we're going to just print noise collector BLE. That's it. And now we should create a cmakelists.txt file with the minimal build instructions for the project. So let's do that. Let's go here, let's create the file. So that should be make lists.txt, and here I'm going to add the minimum configuration for this project, which is the minimum version of CMake that we require, the name of the project and that it uses C++, and the name of the file that is included in the project, in this case just the main.cpp file. Before we move forward, we are going to check that it all works fine. So let's create the build directory here, and let's use the CMake file that we created with the build instructions with this directory as the source code and the build directory that we have created to do all the building process. It does the configuration, it creates a make file over there, and now we can try to run this binary creation that we have configured in the CMake lists.txt, and we can even try to run it. And it prints exactly what we have in the main.cpp file. Now that we have set the foundations for the project, we can send our first message to DBus. A good one to start with is the one that we use to query if the Bluetooth stack radio frequency is on or off. Let's start by adding the library to the project using CMake's find package feature. So here we're going to use find package, asking for the sdbus-c++ and setting it as required. Once CMake is able to find the sdbus-c++, we want to link it to the binary, and we do so by adding this other statement here. And this library has a requirement that it wants the code to be compliant with the C++ 17 standard, and we want to enforce that here. So we add these two parameters here, enforcing the configuration of the C++ standard to be required. So with all these pieces done, I save this and I close this and go to the creation of a new file that is going to be the skeleton of our definition of a BLE sensor. So let's go here, let's create a new file. The file is going to be blesensor.h for the header, and we are going to define the basic skeleton of a class definition. Inside of the class definition, we are going to have two public methods. One for the constructor, blesensor, another one for the scan and connect method. That is what we will be using right away. These two methods are public, but we would also want to have some private part in this configuration. In this case, we want to have a unique pointer that is having the proxy that connects to the Bluez stack through the DBus. This proxy is a local object that allows us to interact with the remote DBus object. Creating the proxy instance without passing a connection to it means that the proxy will create its own connection automatically, and it will be the system bus connection. We have the Visual Studio Code complaining here because it doesn't know what an SDBus proxy is, and that's because we haven't included the header for the library that we defined before. And we can indent things properly, and that's basically it. That is like our first version of the BLE sensor header. Okay, so let's go now and create another file here that is going to be the implementation of this BLE sensor. So that would be BLE sensor.cpp, and we're going to include here the header that we have just defined. We would like to have here implemented the methods that we have defined before. And the first thing that we want to have is the constructor. In the constructor, we're going to initialize that proxy that I was mentioning before. So in order to do that, I'm going to need the parameters for this proxy. And the parameters are going to be these two constant strings: the connection, that is the .bluez object, and the object path, the instance that we are talking to. In this case, this is going to be the host controller interface 0. So basically, the chip that we have in the Raspberry Pi to provide us with Bluetooth. The other thing that we want to do is use these two parameters and create an instance of the Bluez proxy that is a member of our object here. Okay, so what else do we need here? Well, besides this method, we were going to implement the scan and connect method. But in order to make that a little bit easier, I'm going to add a private method here. So this private method is going to be a method that talks to the DBus using the proxy that we have just created and requests the state of a property that is going to be whether the radio of the Bluetooth stack is powered or not. So we are going to use that property here, and we would like to have this private method implemented using first this high-level interface that the DBus-C++ library provides us with, that using this proxy, we can have an invocation to the method on that interface with these arguments and store the results in this variable. Once we have that, we will be returning the variable. But before we do that, we need all these constants to be defined. So let's go step by step. And the first thing that we're going to do is define where we are going to store the data. Let me remind you from the previous episode that a variant is a variable that allows us to serialize different types of data. In this case, it's going to be a Boolean, and that's why we do the casting here. This is not actually a casting, a traditional C casting, but rather is an overloading of the parenthesis operator that is used here to transform this variant into the actual value that we're looking for. And here we're going to define the 4 constants that are used in this method. So we need to get a property, that is where the get method is, and the property that we're going to get is whether it is power or not, the radio, and that property is in this interface. Okay, so that's basically it. Now we have the private implementation, and what we would like to have here is the public one. The public one is basically going to use this one, the one that we have just defined, and print whether the radio is already on or whether we are going to turn the radio. Before I add the IO stream, we are going to surround this with a try catch, just to be able to find. Let me move this here. And Okay, so now if we have any problem connecting to the DBus here, we will get an error and we will get this error printed on the screen. We can add the IO string here to avoid those complaints that we were getting from the compiler. So now it's perfectly fine. And now that we have the public method completed, we can go and implement this method in the this main.file. But before we do that, we would like to have the CMake list updated. So we include not just main CPP, but also the BLE sensor file that we have just created. So in order to do that, we're going to have this globe defined. Let me move it up a little bit. And what it does is it uses this globe to say, I'm interested in any CPP file in the directory, and please add them with this variable to the executable. Okay, so that's done. Let's go to the main CPP and let's use the things that we have. In order to be able to use them, we need to import to include the header. So the definitions are available to this file. And here we're going to create an instance of the BLE sensor. So we create an instance in line 8, and we use the instance that we have just created in order to invoke this method that at the moment doesn't do the scan and connect yet, but it verifies whether the radio of the Bluetooth is available or not. So that should be it, and now we should be able to run this. So we can do CMake and then build, and this is the directory that we want to build. So it is compiling, and hopefully in a second it will be running when I say start build noise collector BLE. So we get the initial print of the program, and then we have a message here saying that Bluetooth is already powered on. Our first message querying the status of a property. But we can also use DBus messages to change the state of a property. In this case, we're going to change the state of the Bluetooth radio. We are going to declare the second private method, and we do it in our header. Here we define this declaration that is a method that allows us to change the Bluetooth status, enable it or disable it. And we are going to save this and go to the implementation, where after the other method, the other private method that we created before, we're going to create a declaration for this. So this is going to be the declaration of the method, the implementation of the method, and here I'm going to do basically the same thing that I was doing before to get the value of the property. But in this case, I'm going to set the value of the property. Notice that most of the constants are the same. So interface properties is there, interface adapter, property powered, everything should be the same, but the get method that in this case I'm getting, and here I'm setting something. The other thing that's different is that I'm using this don't expect reply here, because that is another way that is provided by the library to fire and forget. But if we do that, we don't know when the operation is done. So instead of doing that, I'm going to replace this with the store results to, as we were doing here, but we are not storing any results. So we leave this empty. Okay, now that we have created the method invocation, we are going to go here and define the only constant that is different. So that will be the one for the set method. The other three are exactly the same. So we don't want to repeat the definition of this constant. So instead of that, we're going to go here and select the three ones that we have and delete them from here. Instead of having them here, we're going to define them in the other file, in the header. So we're going to go to the header, and here I'm going to define these three constants as a static. And taking advantage of the C++ 17 initialization, we're going to initialize them in the header rather than in the implementation file. Using the inline static, we have just this single line that declares the constant and initializes to the value that we provide here. So that should be it. Now we have this implemented, and what we can do is to use this code in the implementation in the public method that we had. So let's go there. Let's go here. As you can see, there are no errors anymore. And we can go back to the scan and connect method. That is the public one that we were using before. And here, if I get the Bluetooth status and is false, then I will be powering the Bluetooth on. So let's go here and let's use the method that we have just defined, and we use it with the true value to enable the Bluetooth radio. So that's basically it. Now we can use this in the command line, and here we're going to use CMake, we're going to use build, and use the build directory. We're compiling the code, and when the code is, the binary is created, we can then use build noise collector BLE and execute it. As you can see here, the Bluetooth is, at the moment, is power on, but if I use Bluetooth CTL and I power it off and exit from this tool and execute the command again, it says that it is powering on. And if I go to Bluetooth CTL and I show the status, now it should be powered. And it is. Okay? So that's it for the second message sent to the DBus. The next thing that we would like to do is to start scanning for BLE devices. Find our sensor, connect to it, and stop scanning. Obviously, not all of the BLE devices that are surrounding us will be answering right away. Some will do it immediately, some will take more time. We will be receiving signals, asynchronous bits of information, that are pushed onto an object and that we will be listening to. We are going to use a private method to take care of enabling and disabling the scanning. And the first thing that we need to do is to declare that in the header. So let's go to the header and let's declare the method. That method is going to take care of both scenarios. So by sending the Boolean flag, it will either enable scanning or disable scanning. And now that we have this declared, we are going to go to the implementation. And here I'm going to go to the end of the file, and I'm going to create the declaration of this new method that we have just defined. The first thing that we want to do is to print a message here that will depend on the Boolean flag that we set to it. But the rest of it is going to be very, very, very similar to what we have done so far. So we're going to call a method. We're using this Boolean flag to send one message or another. We haven't defined these constants yet, but the interface adapter is already there. And in this case, we really don't have to wait for anything because the sensor has to be replying, but not right away. We will see that in a minute. So let me declare here the two constants that we are interested in, the start discovery and the stop discovery constants that are going to be used as the method here. And now that we have this defined, we can go and use that here after we have enabled the Bluetooth radio. So here we can go and execute this same method, first enabling a scanner and then disabling the scanning process. Well, if we do that, it's not going to really work because it will stop scanning almost immediately after enabling it. And we want to wait for results. So what we're going to do is to add this wait for results here. Let's have this. And we will wait for 10 seconds before we do that. This complaint here is because we haven't had the proper headers in order to do that. So let's go to the beginning of the file, and I'm going to include chrono for the time and thread for the sleep that we have here. So chrono for this specification of the number of seconds, and this thread comes from the thread header. So now we have this, and we should be able to compile this and execute it. So let's go with cmake build, and it will compile my code and it will generate the executable. And if we execute it, we will see that it starts scanning, it waits for 10 seconds, and then it prints the stop scanning because the method is invoked again. So far, so good. In order to gather the data that scanning for devices produces, we need to be listening to the signals that are sent through the DBus for everybody to listen to. In order to receive these signals, we need to interact with a different DBus object. So we need another proxy. Let's get this out of the way. Okay. And let's declare this proxy in the BLE sensor header. So after the one that we already have, we declare another one that we are going to call root proxy. And obviously, we also need to instantiate this proxy. So we do that in the constructor. So here, after the proxy that we have defined to send the messages to DBus, to Bluez stack, we are going to create the instance of this other proxy. In this case, the path is going to be the root path because we want to listen to all of the messages. And then with this instance created, we can define another method private method that we are going to use. So let's go to the header, and here we're going to define the private method. This method is going to be able to be used in order to subscribe to the signals that are coming due to an interface added to the Bluez system. So let's go to the implementation and let's implement that method. Here we define the method, and here we are going to invoke this API that is different from the calling one that we were using before. So upon signal, we are going to call this interface added callback that is not yet defined. So let's go step by step and let's define this interface, the object that the interface, the member that we are going to be paying attention to, which is an interface has been added, and then we will take care of the closure that we have defined here. So these are the instance and the member that we will be listening for. And now we define the Lambda function here. Notice that I am capturing this because I want to access to the object instance. And I receive these two pieces of data, the object path for the object that has created the signal, and this dictionary that uses string and values inside of the string that will contain the data for the interface that has been added. Now we are going to add the implementation for this interface, and that is going to be this one. Let's review it one step at a time. So here I'm going to use regular expressions, and I'm looking for a match in the object path. First, I print the information about the thread that this method is running on, and then I try to get a match for a regular expression that I haven't defined yet. And if I find a match for it, then I will try to look into the interface, see if it has the name field defined, and if it does so, then I will try to use this name to print it on the screen. If it doesn't have a name, then I will say nameless at this object path. Okay? So the next thing that we need to do is to define that regular expression. First, we're going to include the header. Let's move this to the header, to the includes here, and I'm going to paste that here, and I'm going down to the implementation that we had, and I'm going to define the regular expression that we are going to use. Notice that this is the typical path that DBus shows. In this case, we're going to get or Bluez as the beginning of the path because the data is coming from the Bluez implementation. Then host control interface number 0 to 9. Actually, we only care about the ones that come from host control interface 0, but we have made this a little bit more permissive. And then we will be having information about the device MAC address. So this is a way to refer to the MAC address, and this dollar means that the expression ends here. It is not optimal to have this regular expression defined here because it has to be compiled every time it gets to this closure, but at the moment performance is not an issue, so we're going to leave it here. So now that we have this private method ready, we are going to use it. and we're going to use it in the public one that we had before. So let me remind you that we have this scan and connect, and before enabling scanning, we are going to add this invocation to subscribe to interfaces added. Then we will be paying attention to all the things that we have around us. So let's do that, and let's have this invocation ready. And now we can just print on the main thread. Let's put it here at the beginning of this method, the information about the thread that we are running on. In this case, let me get rid of this one, and just to compare both things. Let's save and run, and if we build it again, we will have this capability running, and hopefully like this here, I'm going to be able to run this, and yeah, we get a lot of information about devices that are around us. So we get this Bluetooth, power on, start scanning, and then notice that this thread ID and this thread ID, the one that Scan and Connect is running on, are different. So we get the information about the signals in this other thread, and this is our RP2 sensor that is the one that we will be connecting to. We stop scanning after 10 seconds and we're done. In this episode, we have learned how to use the DBus-C++ library to send messages to the DBus and interact with Bluez, the Bluetooth stack for Linux. We haven't finished though, and there are more messages that we want to send and other ways to interact asynchronously with DBus. But meanwhile, you can use this link or scan this QR code and have access to the full repository of the code of this episode and next episode that is together. Meanwhile, stay curious, hack your code. See you next time.